Hi there. What we're going to be working on in this video is how to solve rational inequalities. So this is a very similar process as to the one for solving equations, but there's one very important step. And that step is that we are going to be testing intervals on our number line to see regions of numbers that work, intervals of numbers that work. When we have the numbers on our number line, they can be either open or closed. So first of all, any values that would make our denominator equal to 0, we would put those on our number line as excluded values, and they would be put on as open circles. Beyond that, we have to look for the symbol in our inequality. If our symbol is greater than or less than, that would also give us open circles on our number line when we look at our numerator. And as in this case, we have a less than or equal to symbol, that would result in a closed circle on our number line because we can have 0 in our numerator. We simply can't have it in our denominator. So I have the steps listed here. I also have them listed on the problem as we're going to work through the problem. So let's take a look and let's just jump right in. So I'm asking you to solve this inequality, and the first step is to set the right side of the inequality equal to 0. So we'll have x minus 2 over x minus x minus 4 over x minus 6, and we bring down our symbol less than or equal to 0. Now, it's already factored for us, so that's nice, nothing to do here. But looking at our denominator, we can see that x cannot be 0. And over here, if x was 6, our denominator would be 0. So we have an open circle at 0, and we have an open circle at 6. We have to extend our number line for this one. Okay, so now what we're going to do is we're going to combine our fractions, which means we have to get common denominators. So I'm going to multiply this fraction by x minus 6 over x minus 6. And I will be multiplying the other fraction by x over x. That will give us one big fraction, which is going to be a very important fraction for us. So we will get, and I'm going to FOIL it right now so I don't have to keep rewriting it, we would get x squared minus 6x minus 2x, which gives us minus 8x, plus 12, minus, and now I'll distribute that x in there, putting brackets around this, you should probably think about why, x squared minus 4x. What I hope you realize is this whole fraction is being subtracted, which means we have to distribute this negative. So we get plus a negative and a positive right there. Now let's combine our like terms. X squared minus x squared, they cancel out. That's good news. Negative 8x plus 4x gives us negative 4x. Plus 12, and our denominator remains x times x minus 6. Bring down your symbol. Now, this is the step we're going to use in a moment. We've combined our terms. We've made one fraction. So we're going to hold that for a second. I like to mark it off. And at this point, we're going to look at our numerator, and we're going to set it equal to 0 and find the values from the numerator that would equal 0. So move your 12 over, divide. We get x equals 3. So what that tells us is 3 is an important number on our number line. And looking at this, we have a symbol less than or equal to, which means 3 is part of our solution. So it's a closed circle there. Again, if the numerator, if this symbol is greater than or equal to or less than or equal to, that would give us a closed circle when we solve for our numerator. Okay, what have we done here? Well, we have 3 important points, 3 critical values on our number line, which essentially breaks our number line into 4 regions. We must test a number in each one of those regions in this fraction right here. And we're looking for values that when we drop them in, they are less than or equal to 0. So let's go ahead, let's see what we get from that. So we will get let's test to the left of 0. I'm going to test negative 2. Between 0 and 3, I'm going to test 1. Between 3 and 6, I'm going to test 4. And greater than 6, I'll just test 7. Now here's what's nice. We're just going to drop these numbers in here and we're going to look for the sign. Is the number positive or negative? And see how that all shakes out as it compares to 0. So if I drop -2 in here, I get positive plus 12, which is a positive, right? 8 plus 12 is a positive. And then I would have a negative times a negative in my denominator, which is also a positive. So a positive divided by a positive is a positive. That is not less than or equal to 0. So this will not be part of our solution. Let's test the 1. When we drop a 1 in here, we get -4 plus 12, which is 8. So that's a positive over a positive times a negative. Well, this is then positive divided by a negative, which is a negative. A negative is less than or equal to 0, so that is part of our solution. So all of these numbers in here, that would be part of our solution. Okay, let's keep going. We're now going to test our 4. -4 by 4 is -16 plus 12 is a negative divided by a positive times a negative. And again, I'm just dropping the numbers in here. We don't really need to know the number as much as the sign. We get a negative divided by a negative, which is a positive. A positive is not less than or equal to 0. So that is not part of our solution. And the last one we're going to do is a 7. -4 times -7, -28 plus 12 is a negative divided by, drop a 7 in here, we get a positive times a positive. So we have a negative divided by a positive, which is a negative. A negative is less than or equal to 0. So everything greater than 6 will be part of our solution. So our solution goes from 0 to 3, including the 3. So 0 to 3, we'll put a bracket on the 3. Union, which means there's more to come. And then from 6 to infinity, not including the 6. So that would be a parenthesis to infinity. And that right there is our solution set. You can see it on your number line. We need to see it on your number line, but I also want to see it in interval notation. Okay, let's go try a second one. So looking at this one, a couple things are nice. Number one, it's already got the 0 on the right side, and it's only one fraction, so we don't have to get common denominators. We just have to deal with what we have in front of us. So let's go ahead and factor our numerator. That's an easy factoring, right? X minus 3 times x minus 3. And in the denominator, all we can do is take out 3x. We just have a GCF here. So 3x times x plus 4. Okay, let's look at our denominator and find our excluded values. So we know 3x cannot equal 0, so x cannot equal 0. So that's an open circle here. And x plus 4 cannot equal 0, so x cannot equal -4. That gives us another open circle right here. Okay, we have dealt with our denominator. I'm putting that like that because I want to make sure I can find it when I need it. And now let's take our numerator and set that equal to 0. So x minus 3 times x minus 3 equals 0. I think that's a pretty easy one, right? X equals 3. And again, just like the previous problem, we have less than or equal to here, which means we will have a closed circle on 3 because the numerator can be 0, right? 0 over anything is 0. Look at our number line. We have 4 regions to test. So I'm going to drop -5 in. I'm going to try -2 because that's between -4 and 0. I'll be testing 1, and you can test 2 if you want. We'll get the same answer. And I'm going to test 4. And again, you can test 5, 10, 100, because that's anything bigger than 3. Okay, let's drop our numbers in. Let's see what we got. Dropping -5 in here, I'll have a negative times a negative, which is a positive, over a negative times a negative, which is again a positive. So is a positive number less than or equal to 0? No, it's not. Let's try our -2. -2 dropped in here, we get a negative times a negative, which is a positive, over, we get a negative times a positive. So a positive divided by a negative is a negative. A negative is less than or equal to 0, so this is all part of our solution. Okay, now we're going to test between 0 and 3. I chose 1. Again, we have a negative times a negative, which is a positive. Hopefully you realize it's always going to be a positive, right? And then we have a positive times a positive, which is another positive, right? A positive divided by a positive is a positive. And as we said before, a positive is not less than or equal to 0, so this is not part of our solution. Let's test our 4. A positive times a positive is a positive, divided by a positive times a positive is another positive. So that's a positive right there. Not less than or equal to 0, so not part of our solution. So we have a very limited solution set here. Now be careful, because watch this. It's from -4 to 0, not including the -4 or 0, and 3. That is our solution. Okay? So hopefully that made sense. Let's try one last one. Okay, what you'll notice is we do not have a 0 on the right side, so that's the first thing I would do. 3 over y minus 2 minus 5 over y is less than 0. Looking at the excluded values from our denominator, we simply know that y cannot equal 0, so that's an open circle here. Now, we need to get this to be one big fraction, so I'm going to multiply this by y over y, giving us common denominators. Okay, and let's combine what we can. So we'll have -2y, and then 3 minus 5 is -2. Bring down the less than 0. So now we focus on the numerator. We've already dealt with the denominator. We'll set that equal to 0 and solve. Add the 2 to the other side. Divide by -2. We get y equals -1. Now, it actually said less than 0, so this would be an open circle at -1. We just temporarily set it equal to 0 so we can solve it. So we have 3 regions to test. We have to test to the left of -1, so I'm going to try -2. We have to test between -1 and 0. I'm going with -0.5 or -1/2, however you'd like to write that. And then I'm going to test 2 to the right of that. Okay, greater than 0. We're going to drop our numbers right in here. So looking at this, I'm going to make my fractions. Okay, if we drop a -2 in here, we get 4 minus 2, which is positive, divided by negative is a negative. Well, we wanted the numbers that were less than 0. So this is part of our solution. So everything from -infinity to 0 is part of our solution. Let's go ahead and drop our -0.5 in here. -2 times -0.5 is 1. So 1 minus 2 is a negative over -0.5, another negative. That's positive. So that excludes the numbers in between because we were looking for numbers that were less than 0. Oops, it erased it. Now we're going to drop a 2 in here. -2 times 2 is 4. 4 minus 2 is a positive over a positive. Oh, I'm sorry. That was a negative. My mistake. -2 times 2 is -4 minus 2 is -6. divided by a positive, that gives us a negative value. That's what we wanted, so this is also part of our solution. So our solution goes from negative infinity to -1, not including the -1, and from 0 to infinity. So the only numbers that were not going to work for us are between -1 and 0. Okay, everybody, I hope this was helpful. Have a wonderful day.